once the existence of the atoms was accepted, the next question was, what do atoms look like? J.D. Thomson with other scientists made clever experiments to answer this question. It showed that atoms are not fundamental particles of matter. Instead, they are composed of even smaller particles.
J.J. Thomson was a British physicist who was born in Manchester during the mid-1800s. He made a number of experiments during his lifetime, whereof many he became known for. His most recognizable discovery was from these experiments is the identification of the electron, the very first subatomic particle. This he did by his well-known cathode ray experiment. Sadly, Thomson passed away in 1940, leaving him 83 years old.
Like Arian said, Thomson made the discovery of the electron by the cathode ray tube experiment. A cathode ray tube is a sealed glass tube from which most of the air has been evacuated. Inside of the tube there are two different electrodes in two different sides of the cathode. On one side there is a positively charged electrode which is called the anode. On the other side we have the cathode, which is a negatively charged electrode. He applied a high voltage across these two electrodes, from the cathode to the anode, which causes a beam of particles to flow between these two electrodes.
On the opposite side of the tube there is a coating that glows when struck by electrodes. Thomson painted phosphorus on the far end of the tube, beyond the anode. When you do that, the ray can be detected. Then he placed two oppositely charged plates around the cathode. The cathode ray, the beam of the negatively charged particles, was deflected away from the negatively charged electric plates and directed towards the positively charged electric plate.
Here we have our own cathode ray made of blueberries. The blueberries represent the negatively charged particles in the ray. When we take a raspberry towards the ray of blueberries, the blueberries get deflected away since the raspberry represents the negatively charged electric plate. And when we take a strawberry towards the beam of blueberries, the blueberries move towards the strawberry since the strawberry represents the positively charged electric plate. It was by the experiment Thomson discovered the negatively charged particles, the electrons.
Now, Thomson knew two things that he based his atomic model on. 1. An atom contains small negatively charged particles. And 2. An atom behave as they are electrically neutral. His conclusion was that it had to be a positively charged source within the atoms to neutralize the negatively charged particles. Thomson considered three alternative models that could satisfy the qualities of atoms at the time. He chose one of them, the plum pudding model, as the best model to show how atoms looks. The plum pudding model proposes that atoms could be described as negative particles floating within a soup of diffuse positive charge.